In Section 3, we'll take a look at some issues related to creating windows. Now that you have a good understanding of what it takes to create a Windows program, let's start working with creating windows. First, we'll take a look at how you create windows. Then we'll take a look at how you create window classes. Move on to taking a deeper look at the differences between windows that have parents and child windows and the other styles of windows. And finally, we'll review a little bit about message traffic to help you really pin down an understanding of the importance of the window procedure as the arrival point for all messages and the determiner of what the window actually looks like. In this module, we'll take a look at how you actually create windows. Then in the laboratory, I'll have you go and add a second window to a sample program so that you'll have one program, one task queue, and two windows. In this lecture, we're going to take a look at the concepts embodied in the way windows are put on screen, and also take a look at the styles of window. Then we'll turn to a detailed look at the actual call of create window. And I'll send you off to do a lab to create a second window. The most important point to emphasize about windows is that windows are really owned by tasks. Tasks, after all, are the things that are scheduled by the scheduler in Windows. And when a task is scheduled, some of its code starts running. Part of that code is WinMain, and it's pulling messages out of the queue. Other parts of that code are window procedures, and it's the window procedure that handles all of the input for a particular window and negotiates, if you will, between the user and the windowing system. Now, the process of creating a window, you've seen, involves at least 4 steps. You have to register a class for that window. You have to create a window of that class, then show it on the screen, adding it to the set of windows which are currently known to be on the display, and finally updating the window, which is a way that you call the window procedure to have it do the drawing in the client area. There are 3 basic styles of window. We'll see that the style parameter to the create window call is multiplex in terms of the information it contains. But one of those pieces of information is a choice that you make as to the style of the window. That is, whether it's going to be an overlapped window. Typically, the overlapped is the top-level window, the main user interface between your application and the user. You may build pop-up windows. Pop-up windows, I like to think, are there because we needed them for dialogues. And because we needed pop-up windows for dialogues, we make them available to you. The interesting thing about pop-up windows is that they are conceptually in front of all of the overlapped windows. It doesn't matter how many overlapped windows there are on screen, the user, when you post a pop-up, will be able to see it. Finally, there are child windows. Child windows are a particular form of additional window. Child windows are always children of either a pop-up or of an overlapped window, and they're a way for you to structure your client area. Once you have created a window, when the user begins to work with that window, moving the mouse through it, making mouse clicks, typing keys at it, and so forth, it is the window procedure for that window class which handles the input from the task. In your workbook, you've got a picture that I like to use to help remind me of the importance of a window procedure. You see that the task queue and the WinMain are directly associated. The task queue here really stands for all of the instance data related to this particular window task. And you see that the WinMain dispatches to the pop-up Windows procedure, it dispatches to the overlapped Windows procedure, and to the child Windows procedure. And ultimately, those procedures then alter the instance data, or they may alter the appearance of the window on the screen for the user to get feedback. but that procedure stands directly between the WinMain and any changes on the screen. All messages in the system go to exactly one window procedure. Now by that I mean that there is no inheritance. For example, if you have a child window and the user moves the mouse into the region of a child window and makes a mouse action or something, the child window procedure will get the mouse button activity. If the child window procedure doesn't handle it, that message will get passed on to def window proc. But in no case will Windows discover that nobody's handled the input and send it on to the parent. Similarly, if a parent has a message that it doesn't handle and there's a child that's in the same general region, Windows will not take an unhandled message from a parent and pass it on to a child. There is no inheritance hierarchy in Windows. In fact, all window procedures are exactly equal when it comes to taking input out of the task queue. When it comes to Windows, there are 4 basic features that distinguish various windows one from another. They have a style, that is, whether they're pop-up or overlapped or some of the other informative pieces of data that I'll talk about in a moment. They have an ownership. Now, the owner is really the task queue through which this particular window will take its input. That's what the purpose of the ownership symbol is. There's a procedure associated with that window. The procedure was established at the time you registered the class. And finally, it has parentage. The window may or may not choose to have a parent. We'll talk more about that in a bit. So, in terms of the style parameter as part of the create window call, first thing that you need to decide is whether you want your window to be pop-up or overlapped or a child window. Having decided that, you then get to mix and match another set of bits, if you will. Notice that these are all stylistically defined for you in Windows.h. What you're building is a bit string that is the value you'll use for the 32-bit DW style in the create window call. In addition to specifying whether you want your window to be overlapped, pop-up, or child, there's a lot of other information that gets packed into that double word, the style parameter. The first set of informative bits that you can add to that parameter include what you request for the initial state of this window. Is it to be visible or disabled? Do you want it minimized, which is the same as iconic for backwards compatibility, or maximized to occupy the full screen? You add those bits in by ORing them. There's a lot that is important about building the style parameter. You start with the overlap or the style that you want, and then you add these other things. The next piece of information that you can add is information that Windows will use to aid it in clipping various parts of your client area. In particular, if you know that you have a parent window which is going to create children, and that there is some chance that the child window and the parent window may try to write on the same area of the client area, same portion of the client area, then you can add to the parent's style bit, the overlap window style bit, or the pop-up window style bit, the WSClip children directive. That directive says to Windows that you want it to take on the additional work necessary to keep the child from, or the parent from writing on or drawing on any of the pixels that are owned by any of its children. Similarly, when you create child windows, you can specify that GDI and the Windows subsystem is to take on the additional clipping work necessary to keep the children from writing onto portions of the client area which they might otherwise share. And in order to specify that you want Windows to take on that burden, you specify the WSClip siblings bits. In general, all but one of the children need the WSClip siblings bit on. Once you made all those decisions, you now get to decide how do you want this window to be decorated. I mean, after you told us to create it, what do you want us to have as part of it? Do you want a minimize box? Do you want a maximize box, a border, or a caption, or a dialog frame? A system menu, or a thick frame, or a vertical scroll bar, or a horizontal? Those are bits that you also add into the style. Now, once you've made your decision about how you want something to work, and what all it is that you want in the style, then what you do is you set your style bit to be the OR of all of the symbols that you want. For example, here I specified that I want an overlap window whose children are clipped from it. Or I may want a pop-up which is visible. Pop-ups are not, in fact, automatically visible. Or I may want a child that has a caption bar and which has its siblings clipped, and so forth. So you build the style parameter in that way. So now we've looked at a number of features that are going to have to be part of the create window call. We're going to have to specify the task queue through which the window will take its input. We have to specify the class, so Windows can figure out what procedure is going to be the WinProc for this window. We have to specify whether there's a parent or not. We have to specify a child. And in fact, there are a number of other parameters. 4 of them relate to the origin or the location of the window on screen. These coordinates are, in fact, device coordinates. I haven't got a whole lot that I want to say to you about that. We'll return to that a couple of times through the course. But here, then, is the create window call. It's got a lot of parameters, but that's the reason that you're going to go into a lab next. In the laboratory for this module, what you're going to do is actually add a second window. And I'm going to have you add an overlap window to a program that you're working with. What you'll wind up with is a program whose output will look very much like this. That is, it'll have one window, where I've been using simple. You'll see that recurring a lot. In fact, if you like, what you'll discover is you can take one copy of simple and perform each of your labs on it, gradually adding to the thing until it grows and has bells and whistles and so forth. It's a different thing than your class exercise. It's more of, I call it the Popeil fisherman. You know, it's the 12-in-1 window thing. But it'll have a second window. Now notice that they both look the same. They're the same class, these two windows. They're mutually independent, both of them reading from the same task queue. And that's why they look the same. They have actually the same behaviors because they have the same window procedure. I want you to go to the laboratory, work with this, create a second window of this sort, and when you've got that second window working, come on back, because the next thing we've got to do is add a second class. Welcome back. Now that you've studied windows and their creation, let's work with actually adding a window class. In the laboratory, once you've learned about what a window class is, I'm going to have you register a second class and make sure that your second window is of that class. And now you can start to make the two windows that you've got for your one task look different. So I've said before, once you've got a window that you created of a class that pretty much was boilerplate to you, what you need to work on now is adding an extra window class of your own. Window classes are created by registration. And instead of a series of parameters, as we saw in the create window call, what you hand in is a single parameter. And that parameter is a data structure, and so you have to fill in all the pieces of that data structure. Clearly, the most important pieces, at least the way I look at it, the most important pieces of the window class data structure are, first of all, the name of the class. That way, when you try to create a window later on of that class, Windows will know what you're talking about. The name, if you will, becomes the handle to the class. The other thing that is of interest there is the handle to the instance. Now, in the case of create window, the handle to the instance was used to specify the task queue through which messages would be received by the window. I like to think of the H instance in the case of the register class function as actually being more related to where's the executable file. That is, what executable file out there on disk can be used to retrieve the window procedure when it gets lost, because we know it will over time during the use of the Windows system. And then the other thing that's incredibly important is to have the procedure. What you get back then from the register class call is the knowledge that you can be secure that Windows knows all about that class. It knows where the procedure is. If the procedure isn't there, it knows where to retrieve it again from the executable file. Windows is all set to create windows of the class that you name. Well, that's not all of it, though, because there's another parameter in there. There is a class style. Buried deep in the middle of this data structure is a class style. Very much as with the window style, the class style includes a whole lot of bits that are Some of them are related to performance, some of them are related to the behavior of windows of that class. In particular, taking a look at the styles that are available to classes, you can optimize performance by requesting that windows do byte-aligned text. On some devices, it turns out that writing text at 8-bit alignments is much faster for the frame buffer, for the text subsystem. So that can be a performance optimization. The system is, of course, free to ignore the request on your part, but it is a specifier that you can put in. Save bits tells Windows that what you want is when a dialog box or a menu comes up, you want the bits removed off the screen to a safe place and put back for you. You don't want to have to repair the damage done by these user interface constructs yourself. You can specify that your picture on screen may not need to be redrawn in case the user shrinks the window. Often, for example, in a word processor or a terminal emulator or something, when the user shrinks the window, all that's lost is a certain number of characters to left or to the right or bottom. And you may not require redrawing yourself after that. If you want the window to be sensitive to mouse double clicks, that is, clicks which occur within the double click time, down, up, down, again. We'll take a look at that in the next module when we look at input devices. You specify that as a property of the class. It is a property of the class, and the CS double click simply turns on the receipt of double click messages. You can say that you're really interested in the OEM character set, that is, you actually want the keyboard scan codes. Not recommended because it makes you dependent on a particular keyboard and its architecture, but it may be something you want to do. And finally, we haven't really addressed the issue of DCs, device contexts, which are how you draw on the screen. We'll see that later on when we look at the GDI in greater detail. At that time, you'll learn that there is a cache of DCs for the windows. There are only 5 of them. And the own display, the class DC and the parent DC, are mechanisms you can use to provide a little bit more locality and permanence to the device context in the way in which it stores the way you do drawing. Well, that's a fairly complicated style bit. In general, you'll notice all your examples simply turn on CSV redraw and CSH redraw. No problem. There's not a lot that you need to know, but there is a great deal of richness in that style parameter. And guess what? You build it in the same way you build the window style parameter. That is, you OR all of these bits together and we'll decide how to do things. Okay, now that you know a little bit about the class data structure, you'll be ready to go to your laboratory where you're going to add an actual window class. The result of that lab is going to be something that will look much like this. Remember, before we had 2 windows that looked the same. Now what we've got is 2 independent windows that look different. In fact, this window actually has its own cursor, so that as the cursor rolls across that window, I get a crosshair, and as I go across the other one, I still have the left going up arrow. So go on, add a window class to your application, differentiate that class. I got some suggestions for you as to how you can make the 2 of them look different so you really get the feeling that they're different. Draw yourself some diagrams, think about how these 2 windows and the 2 classes are related to that task, and then come on back and let's take a look then at parenting and children and so forth. Now that you've worked with creating a window and creating a window class, let's take a look at the difference between windows with parents and child windows. And when you've got that clear, I want you to go back to the lab and vary the style of your second window and whether or not it has a parent. Let's take a look at some of the principles of descendant windows and inheritance of attributes. The most important thing to understand is that overlapped windows may not have parents, and they don't participate in this kind of hierarchy except at the very top. Pop-up windows may have parents. Child windows are required to have parents. The way I like to remember this is in my own life, if I move and I pick up my household and I move to another city, all that's required is that I send my brother messages. I send him a letter saying that I have moved. To continue my analogy, it would be very untoward if my 8-year-old came home one day and found a note on the door that said we'd moved. Now you can imagine that there are times when one window would like to have automatic notification for another window that its status has changed in some way. And that's really what parenting is within Windows. When a window is created that claims another window as parent, what happens is Windows turns on an information bit. And it scans through and it says, we moved the parent window, I better tell the child. Or the child has been moved, I better tell the parent. That kind of thing. It turns on messaging back and forth. But there's no real implication of control. In other words, just because I moved my house doesn't mean my brother's household has been moved. Children, therefore, within the Windows framework, not only have the privileges of having a parent, as pop-up windows may have, but are also constrained in many ways by the fact that they have a parent. For one thing, they borrow their own client area. The only place they ever get to draw is on pixels that used to be owned by the parent. The parent cedes or gives away some of its client area to child windows that are part of it. And the other thing that happens with child windows is that they are actually controlled by the parent. If the parent is destroyed, then a child window is destroyed. It's kind of the Egyptian way of doing things, right? And so these then are the principles on which parenting and childness differ. Remember that pop-up windows may claim to have parents, child windows are required to have parents, and child windows get screen area from their parents, they get messages about their parents, and they get put to sleep if the parent goes to sleep. I guess that's a little different than they used to do in Egypt. But in any case, the other thing that I want to re-emphasize at this point is that all of the window procedures for these windows are getting messages directly from the queue. The WinMain pulls the message out of the queue, looks at it, and dispatches it off directly to the procedure. That procedure either responds or doesn't, sending it on to def window proc if it didn't, and returns. So individual messages only go to one place. When you say that some other window is your parent, and for certain messages sent to the parent, Windows will go through and discover, yes, you are a child of that one, and it will send you a message about the parent's behavior. Similarly, when things happen to you, because you've declared a parent, Windows will send messages. But each window is getting its own individual message. There's no inheritance or move of that window all around. And the other thing to notice is that not all styles are valid with various kinds of window. Remember that I said child windows must have parents. Well, in the same sort of way, turning on and off some of the decorations in particular. You can add a menu to a child window, but it won't work for very long because I don't really expect child windows to have menus and that kind of thing. But you can work with that with the laboratory. So let's talk about the lab next. In the laboratory for this module, I want you to go back to the program that you've just built. You've got a Windows application that has 2 classes and 2 windows. And what I want you to do is to vary the style of the second window. Here what I've got is 2 independent windows, each of them of a different class. And, in fact, I have declared this second window to be a child of. They're both at the pop-up level. And so if I destroy one, the other gets destroyed. I want you to go to the lab, work with these bits, turn them on and off statically, and then come on back and let's talk a little bit about messaging and the importance of the window procedure. Welcome back. Well, now that we've looked at lots of different ways to do windowing and taken a look at some of the styles, I want to re-emphasize the work of message traffic. This is mainly to reinforce what you already know. But then I'm going to have you go into the laboratory and actually send a message from one window to another. Let's take a look again then at Windows, WinMain, and window procedures. I want to diagram the things that you've been working with and then add a little value to what we've been learning so far. Most important point I want to make here is that window procedures get their messages from basically three sources. There's the hardware, the timers, the mouse, the keyboard. Hardware events are eventually transformed into messages, and those messages are pulled off the queue and dispatched to a window which will handle those events. There's another class of event that are generated by Windows for you. These I call pseudo events. For example, when the user changes the size of your window, you get a WM size message. When you've got a menu as part of your window and the user makes a menu item selection, you get a menu item selection message. There's no hardware in the system that's directly related or causes these messages to arrive, but they come to you from Windows. I call them pseudo events to really emphasize that they're not directly hardware, but they're device related. A menu to your program is a device. The third source of messages is other programs. After all, there's no reason other programs can't call you and or send messages to your program. Now, in fact, there are two ways that messages arrive at a window procedure. One way is the usual method where messages arrive indirectly from the task queue for that window. This is the case, for example, of all of the hardware event messages, keyboard, mouse, and so forth. They always come through the queue and are dispatched by WinMain and get to the window procedure. But there are other ways. The window procedure, after all, is just a function. It can be loaded, linked, and it can be called directly. And there are, in fact, cases where that is an important thing to do. The concept of send message is one in which the message is actually injected by direct call into that procedure. This is in contrast with the notion of post message, where the message is enqueued, then returns. The difference is that send message is handled synchronously, is the way I like to think of it. That is, by the time send message returns, the action will have already been taken by the window procedure. And that is what I call direct calls into the window procedure, as opposed to the indirect arrival of a message through the queue. Sometimes, therefore, messages are not queued. It's very important that you understand that. Now, in terms of what we've been looking at, the standard way for information to arrive at a window procedure, then, is diagrammed for you. From the task queue through the WinMain into the window procedure, which may make some changes on the screen. Then, if we were to add a second window for the same task, what we've got is messages arriving at the task queue being pulled out by WinMain, sent to the same window procedure, and that window procedure then needs to figure out which of the two windows it is. You've already noticed that that makes some difference in terms of, for example, when do you destroy the task. We've then moved on, and messages arriving in the task queue being pulled off by the WinMain may be headed for one window procedure or to the other window procedure. We've seen that when you create windows from those classes that are related to those window procedures, you can at that time specify whether they're overlapped or children or what have you. But the behavior of that window, the appearance of it, and what it actually does for your program depends on the window procedure itself. Well, got another vision in which we have two actual programs running. The way the user did this was to double-click on your executable file once and then to double-click on your executable file again. And the diagram you got here shows you two task queues, two sets of instance data. So we have two separate data areas, but a single WinMain that dispatches to one of the two window procedures, and then the window procedures, based on which task they're running it, decide which of the windows they're going to be drawing on. Now, that leads us to a restatement of the fact that other applications can post a message to your task queue or send a message, in which case the message really becomes directly a call on the window procedure. And in summary, then, there are three ways for a window procedure to get input. The input can come from hardware, in which case you get a hardware event message. It can come from Windows, in which case you get a pseudo event, like a menu item selection, or it may come from another application completely. Messages may arrive at the window procedure either directly, by a call, or indirectly, having been removed from the task queue after being enqueued. Send message is the call which is synchronous, calls the window procedure as a subfunction. Post message adds the message to a queue. Now that we've learned all of that, we're ready to actually do a lab with it. In this lab, what I want you to do is to go into your window procedure and effectively send a message from one of your applications to the other. One of your windows, to the other. There are a lot of ways you can do that, but I want you to verify. For example, you might say, have one of your windows be the child of the other. So when the parent is destroyed, the child is destroyed. Well, maybe why don't you add a message so that when the child is destroyed, it sends a message to destroy the parent. In that way, the user could click on either of these two windows and have the task go away. Anyway, go and work with this, and I'll see you when you come back. We're ready at that time to start talking about menus and dialogues and the like.